Hello 9th class students. The next chapter which I am going to start for you is atoms and molecules. See, when it comes to SSC examination, this chapter is very important, because in the next year you have a chapter by name structure of an atom, which is again a high weightage chapter, and when it comes to intermediate, again this chapter repeats. Okay, so the foundation which you will be receiving in the 9th class is going to help you understand the chapters in the later stages or the advancement of the topics in atoms and molecules. Okay, so I'm going to start atoms and molecules. It's a bit lengthy chapter and I'll be going in very detail for this one, so watch the videos which I'm giving you now.
Hello friends, this video on Atom and Molecules part 1 is brought to you by examfear.com. No more fear from exam. Let's start our chapter on atoms and molecules. The first question that comes to our mind is, what is atom? Atom is nothing but it is the basic unit of matter. So if you take any matter, atom is the basic unit of matter. For example, if you talk about brick, this is one brick. This is the basic unit of wall. If you see a wall or a building, that building is made up of bricks, right? But actually, if you even break down bricks into various small parts, you will see that it is made of atoms. So for any matter, this is the basic unit. Okay, and it consists of central nucleus. If you see, there is central nucleus here, the one in the red, and then electron cloud. Whatever you see in black is electron cloud. We'll talk about these things in detail in the next chapter. Just understand that atom is nothing but a central nucleus surrounded by a charge of negatively charged electron cloud. This is negatively charged. This is atom. And if you see the view of atom, this is how it is. There is a center nucleus somewhere here, which is very small, and then there are all these electrons. Whatever you see in yellow, red, blue, green color, they are all electrons floating around, jumping around, and these are all electron clouds. Both are same thing, actually different representation. They actually, if you see here, the speed at which the electrons are moving is very slow. That is just to represent, just to show you that it is there. But actually in the atom, these electrons move at a very high speed, and you see electron cloud kind of structure. Same thing in the fan. If you see, fan has 3 wings like this, but the fan rotates at a very high speed. You don't see the wings, right? Same thing here. There are electrons and they are moving around at very high speed, so you see electron cloud, but actually they are electrons. And if you decrease the speed, you get a view like this. You can't decrease the speed. Just for imagination, we have created this picture on the left hand side, but actually it is something like this. Okay, so matter is the atom is the basic unit of matter. You take any matter, you take apple, you break apple into small part. The smallest part which you get will be atom, and that is not visible through naked eyes. You can't see that, right? And then what is molecule? The chapter is all about atoms and molecules. Molecules are group of 2 or more atoms. For example, I have a hydrogen atom, or I have, let's suppose, 2 atoms. 2 atoms can combine to form molecules. Even 3 atoms can combine to form molecules. 4 atoms can also combine to form molecules, and they are neutral, electrically neutral. There is no charge. So the definition will be neutral group of more than 2 atoms. That is called molecule. For example, H2O, water we drink, is H2O. It has 2 hydrogen and 1 oxygen molecule. 1 oxygen and 2 hydrogen molecules. Actually, it will be something like this based on the size. Right? This is oxygen, this is hydrogen, and this is hydrogen. And when we talk about the ions, we'll talk about these things in details. Just understand these terms now. They have charge. For example, Cl minus, SO4 2 minus. They have charge. We'll talk about these things in detail. Just understand atom is the basic unit of matter. It consists of dense central nucleus surrounded by a cloud of negatively charged electron, while molecule is nothing but neutral group of 2 or more than 2 atoms. This is methane, CH4. There's a carbon here and 4 hydrogens here. These hydrogens and carbons are atoms, and these atoms combine to form a molecule. Okay. Now the next question that should come to our mind is, why should we study atoms and molecules? We know the definition of atoms and molecules. Big deal how it is impacting our life. So if you see, most of the things around us has atoms. In fact, almost everything around us has atoms and molecules. For example, except the light photon, except light, everything you see, for example, coal has atoms, any plastic containers has atoms, soap we use, t-shirts we wear, the toys we play, the tea we drink, the sugar we add, the medicines we take, everything has atoms and molecules. The balls that is used to play, the apple, if you cut apples, you will get a smaller piece which you will not able to cut further, and we will not be able to see that as well. This has to be done in the lab. That will be atom. You take car, you take pencil, notebook, eraser, lab equipment, chemicals, gold, everything has atoms. Everything around us except light. Light has photons, that doesn't have atoms. But except light, anything you see around us has atoms and molecules. The atom is the basic fundamental unit of matter, right? All these things which you see on the screen is made of matter. In fact, the computer screen of the laptop or the tablet or the phone through which you are watching this video is also made up of matter. Even we ourselves, the whole human body is made of matter. Human body is made of protein, molecules. These are all matter, and they are made up of atoms and molecules. Okay. So before we understand atom in detail, let's understand the history of atom. How this word atom came. There was a Maharishi Kannad. This guy is Maharishi, and he was an Indian philosopher, right? And this Indian philosopher in almost 500 BC, almost 2500 years before today's date, he postulated, that time the science experiments were not that much. So all postulates that time. It was all postulates. It was all theoretical. Or theory, you can say. He proposed actually that if we go on dividing a matter, we shall get very small particles. For example, you take apple, you keep cutting the apple, you will get a very small particle. And ultimately a time will come that will come across the smallest particle, beyond which the division is not possible. Right? So for example, you take a brick or you take a pen, pencil, any matter you take. Matter is something which has mass, we just studied in the last chapter. Any matter you take, you keep dividing, and you will reach a point that beyond which the division is not possible. And that particular point, that particular particle which you get, which you can't divide, actually you can divide now, we have seen that, we'll see that, but he postulated that that particular piece which you can't divide will be called as Parmanu. That was the name given. Even atom in Hindi is called Parmanu. Right? There were other Maharishis. They also told that these particles actually, in fact, the name of the Maharishi was Katyamna. This Maharishi told that these particles actually normally exist in the combined state, right? And they give various forms of matter. So they are saying that he told that there are only few different types of atoms or Parmanu, and these are Manu combined to form different types of matter. That's what he postulated. Please note, these are all postulates. There was no experiments done at that time. No experiment to prove. Right? They were all theory. All theory. And at the same time, Democritus and Leucippus, these guys suggested that if we go on dividing the matter, a stage will come after that or beyond which we'll not be able to divide them further, right? And that particle which we get will not be able to divide further will be called atom. So the same particle he called that atom. So Parmanu was the name given by Indian Maharishis. Atom was the name given by Democritus for the same thing. An atom word came from the Greek word means indivisible. A is in and divisible is strong. Atom, indivisible. Please note they are all based on philosophical consideration. There is no experiment done to validate these ideas. These were just ideas. Right? There were no experiments. Let me reiterate this word. There were no experiments. These were all philosophy by Maharishis and Greek philosophers. And that time, if you study history also, you'll see that around BCs and 500, 600 or 1000 ADs, there were no scientists as such. That was the philosophical age. There were a lot of philosophers. They used to give philosophy. Right? They used to think and just say. They didn't have scientific data to prove that. And then now we don't see a lot of philosophers. We see more scientists because we have scientific data to prove a lot of stuff. Okay. So this is the history around 500 BCs. These philosophers, they told that there is something called Parmanu or atom, which is indivisible. You take any matter and keep dividing it, a point will come beyond which you'll not be able to divide that particle further. And that particle is, first thing is invisible, and the second thing is indivisible. And that was called atom. Okay. This is how the atom looks like as per current data. Okay. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on atom and molecules part 2 is brought to you by examfear.com. No more fear from exam. So the two laws came for atom. This came after us. First was the law of conservation of mass and law of constant proportion. These laws actually helped us understand atom better, and these were more experimental. These were not based on the philosophy. These were experimental laws. Let's start the laws of conservation of mass. See, the law of conservation of mass, if you understand one thing, let's take an experiment. You take a matchstick and you burn it. You take a matchstick, you burn it, it's totally burned, right? But before burning it, you find the weight of this matchstick. So let's suppose this is X gram, and then you burn it. After burning, you find the weight. You will see that it is still X gram. The mass of the particle has not changed. This was a matchstick, this is actually ash. Still the mass has not changed. And if you see, burning of a matchstick is nothing but a chemical process. Correct? So you had the matchstick, it went through a chemical process, it became ash, still the mass is same. Right? That means this is a matter, it goes through some chemical process, this is matter A, after chemical process it becomes matter B, but the mass is X gram here also the mass is X gram. This is something we have seen. You can take any other experiments. In any other experiment in the lab, you first measure the quantity of the reactant, just react it, and then do it in the closed beaker so that things are not lost. And then you measure the quantity of the product, the weight of the product. The weight of the product and the weight of the reactant will always be same. You can try this. You can take water and sodium, react it. You can take water or calcium, react it. Right? You just measure the weight of the reactant and the weight of the product, final product. It will always be same. This is experimentally seen. And this is called law of conservation of mass. That is, the mass can neither be created nor can be destroyed in any chemical reaction. Please note, the mass of a state, the mass can neither be created nor can be destroyed. Right? This mass can neither be created nor can be destroyed. In fact, the whole universe mass is constant. It can neither be created nor can be destroyed. Okay? There's only one reaction which you'll see E is equal to mc square. Einstein has given this reaction, which actually talks about converting mass into energy, and c the speed of light. That is a different reaction altogether, where mass can be converted to energy. But in typical reactions, mass can neither be created nor can be destroyed in a chemical reaction. Right? You can just ignore this part as of now, not required for this standard. Just understand law of conservation of mass says that mass can neither be created nor can be destroyed. Weight of reactant will always be equal to the weight of product in any chemical reaction. You take a matchstick, you burn it, weight of this is X, weight of this will also be X. Okay. Let's see another observation. So you can take water, here the reactant is water, and this water can be from any source, right? The water can be from pond, you can take water from river, you can take water from well, you can take water from mineral water, or you can even take distilled water. You have water from different source. If you try this in your lab, you will see that 18 grams of water, when you decompose it, it will actually give you 2 grams of hydrogen and 16 grams of oxygen. You can try this. And here also, if you see, the mass of reactant is equal to mass of product, 18 grams, and this is 2 plus 16, 18. The first law holds true. But here if you see, the proportion is always 2 plus 6, 16. It is never 3 plus 15. It is never 3 grams of hydrogen and 15 grams of oxygen. Or it is never 4 grams of hydrogen and 14 grams of oxygen. It is never. It is always that 2 grams and 16 grams. Why? Why 18 grams of water from any source always breaks into 2 grams of hydrogen and 16 grams of oxygen? Why? You can try this actually in labs. This is true. Right? Or let's suppose you take ammonia gas. So this also, if you break, it will give nitrogen and hydrogen. So if you take 17 grams of ammonia gas, it will always break into 14 grams of this and 3 grams of hydrogen. It's always break. You take any 17 gram of ammonia from any source, doesn't matter, it will always break into this ratio. This is experimentally seen. You must be thinking, why? Why? Why this is happening? There has to be something. Right? These are all experimental data. Please note, we are not talking about philosophy now. These are all experimental data. You take any 80 grams of water, you will get 9 grams of hydrogen, 16 grams of oxygen. Or you take 9 grams of water, then you will get 1 gram of hydrogen and 8 grams of oxygen. Obviously, you will divide everything by 2. Same thing, the same ratio will hold true. If you take 100 grams of water, then you will get 2 by 18 into 100 grams of hydrogen and 6 by 18 into 100 grams of oxygen. the math will all be same. But this proportion 16 by 8, that is always maintained. And why this is happening, right? So with that, a new law was given, that was law of constant proportion. It says that in any chemical substance, the elements are always present in definite proportion by mass. That is, for example, if you take water, then hydrogen is 2 and oxygen is 16. This is experimental data, that is 1 by 8. And why it is 16? We'll tell you. There is a concept of atomic mass and atomic number. So with that, we'll tell you why it is. If you take ammonia, it will always be ammonia, nitrogen will be in the 3 ratio, 14 ratio, and hydrogen will be in the 3 ratio. This is experimentally seen. And why it is like this, we'll tell you. Don't worry. Just understand that these values are fixed for a given compound or given molecule. This is a molecule actually, because this is a molecule which has hydrogen and oxygen as atom. Ammonia is a molecule which has nitrogen and hydrogen as atom. Okay, this is law of constant proportion. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on Atom and Molecules part 3 is brought to you by examfear.com. No more fear from exam. Now, you must be thinking why. Right? Why we have law of chemical combinations? We have two different laws. Okay? And these are all experimental data. Till now, as I told you, water has 2 and 16. That is the ratio. But why is this specific number? Why for ammonia it is 14 and 3? Why? Right? There's so many compounds, you can take so many other ratios. For every compound, you have specific ratio. For HCl, it is 1, hydrogen 1 and 35.5. Why? Right? There has to be some reason. These were all experimental data, but nobody had reasons why it is behaving in such a specific manner. For this, Dalton gave theory in 1808. Please know, not very old, only 200 years old. Dalton gave atomic theory. He told that, first theory, all matter is made up of tiny particles called atoms. This is similar to the philosophy by Indian Maharishi and Democritus. He just confirmed that in his theory. He told that all the matter, you take any matter, you take water, you take laptop, you take anything, that is matter, that is mass, is made up of tiny particles called atoms. The second theory he told was, all these atoms are indivisible. They cannot be created nor can be destroyed. In fact, this theory I marked in green because this proved to be wrong. But this was his theory. He told that the matter atom is indivisible particles. We will see that atoms can further be broken into electrons, protons and neutrons. And in the higher class, you will see that these particles can also be broken into some other particles. So with the current advancement in science, this theory is incorrect, but still that Dalton atomic theory was a big success that time because it helped to give an experimental touch to atom topic. Okay. An atom of a given elements are identical in mass and chemical properties. This is true. In fact, this one, they cannot be created or destroyed, is wrong because they have seen, you'll see that post-Uranium, there are so many elements which are created, they are man-made, and they are created by bombarding alpha and beta and other particles in existing atoms. So that means atoms can be created, right? And atoms can be destroyed. So this theory is not correct. But apart from that, this theory is also correct. They have identical mass and chemical property. We talk about the atom of oxygen, it will always have some property, that is, it will have some particular weight, and it will have identical mass and chemical property. We will talk about that, right? Atoms of different elements have different mass and different chemical property. These are actually both similar, right? I mean, it says that atom for a given element have identical mass and identical chemical property, and an atom of different element have different mass and chemical property. So that means two different atoms can never have same atomic mass, right? These two atoms should have different atomic mass. Chemical properties, I can say to some extent they may match a little bit, but the mass of two different atoms will not be same. In fact, that is the differentiating factor for different atoms. They have different mass, right? And these atoms combine in the whole number to form compounds. For example, 2 hydrogen will compound with 1 oxygen to form water. It's always whole number. It is not that 2.5 hydrogen will combine with 1 oxygen. This will not happen. This will not happen. Okay? It is always in the whole number, never in the fraction. And the relative number and the kind of atoms are constant in a given compound. If you talk about compound, for example, water, the number and the kinds of atoms in this is always same. You take water from any source, it will have same atoms in the same proportion, right? This is the law of constant proportion. So he gave all these theory in 1808, Dalton atomic theory. All these points were correct, but only the second point was not true. Is not true because of the current advancement in science, we are in a position to break these particles, and we, the scientists, have actually created and destroyed atoms as well. Okay. So this Dalton theory actually was able to explain the law of conservation of mass and law of constant proportion. Correct. See, the law of constant proportion, if you see, this talks about the law of constant proportion. Okay, so this was a big success. So let's take some questions now to understand these concepts better. So in the reaction, 5.3 gram of sodium carbonate and 8,2CO3 sodium carbonate, and this is 5.3 gram, react with 6 gram of ethanoic acid. Ethanoic acid is C2H5 COOH. You study about these in the higher classes. 6 gram, and the product was 2.2 gram of carbon dioxide. The product was 2.2 gram of carbon dioxide, 0.9 gram of water, and 8.2 gram of sodium ethanoate, C2H5 ONA, 8.2. And show that these observations are in agreement with law of conservation of mass. So law of conservation of mass says that given the whole thing reacted, right? This was at T is equal to, let me say, T is equal to 0, and this is T is equal to 2. So this was, let me put here once again, this was 0, this was 0, and this was 0. Correct? So T is equal to 0, the reactants were there, the product was 0. T is equal to T, the reaction happened. All these reactants are consumed totally, and we have got this product. So if you see the reaction side, reactant side quantity or weight, so the reactant was 5.3 plus 0.6, that is 11.3, and the product is you add 8.2 plus 0.9 is 9.1 plus 2.2, 11.3. So if you see the reactant and the product matches. So the law of conservation of mass says that the matter can neither be created nor can be destroyed. So in this case, we started with 11.3 gram and we have 11.3 gram. Actually, we should add in this fashion. T is equal to 0. The total volume, total weight was all these 5.3 plus 6 plus 0 plus 0, and T is equal to T. The total weight was these values. So we should have added in this fashion. Right? T is equal to 0, 11.3 gram. T is equal to T, 11.3 gram. There was no change in the mass. So let's take another example. Hydrogen and oxygen combine in the ratio 1/8 by mass to form water. Hydrogen, oxygen, this is 1, this is 8. Right, to form water. What mass of oxygen will be required to react completely to form 3 gram with 3 gram of hydrogen gas? So let's write the first reaction. H2 plus O2 give H2. If you want, we can write the balance reaction as well, or we can ignore for timing. Yeah, since we don't know how to balance the reaction at this point of time. So this is the reaction. It says that if this is x gram, 8x gram is required. And x plus 8x is 9x gram. Right? Law of conservation of mass. So how much oxygen gas would be required to completely use 9 gram of hydrogen? So x, I'll make it as 3 gram. Why? Because that is the question. It has to be 3 gram. So if x is 3 gram, 8x is what? 24 gram. And this is what? 27 gram. So that means 3 grams of hydrogen will need 24 gram of oxygen to form 27 gram of water. Right? 3 gram of hydrogen will react with 24 gram of oxygen to form 27 gram of water. Pretty easy. Because x gram of hydrogen will react with 8x gram of oxygen to form 9x gram of water, of law of conservation of mass. Or law of constant proportion, 8 gram of hydrogen, x gram of hydrogen will react with 8 gram of oxygen. 3 gram of hydrogen will react with 24 gram of oxygen. So this is hydrogen. Now this is oxygen, the big one. This is hydrogen. This is also hydrogen. And this is water. Let's take a few more examples. Which postulates of Dalton atomic theory is the result of law of conservation of mass? So Dalton told that atom is indivisible. Atom is indivisible. The second postulate. And it cannot be created. Can't be created or destroyed. So this particular theory talks about the law of conservation of mass. Correct? So if you see here, the second theory, this theory talks about law of conservation of mass, but this theory is not 100% correct. Right? We have seen that the atom is divisible and you can actually convert the mass into energy by using E is equal to mc square formula. So law of conservation of mass actually holds true for most of the chemical reactions, but that is not 100% true theory. The next question, which postulates of Dalton's atomic theory explain the law of definite proportion? We have told you that the sixth postulate That is, the relative number and the kind of atoms are constant in a given compound. This explains the law of definite proportion. We have seen the sixth postulate that the relative number and the kind of atoms are constant in a given compound. So if you see here, the sixth postulate, this is the one which talks about laws of definite proportion. The relative number and the kinds of atoms are constant in a given compound. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.